Hey Guildies, Fletcher. Today I'm going to be talking about LINQ. I was taking my screenshot there. Today I'm talking about LINQ. A lot of times whenever I'm working with new developers or even mid-level developers who are getting up to a senior level, they're not so familiar with what LINQ is. LINQ. Do I even say LINQ in here? No. Looks like that. LINQ. What that means is language integrated query, is as the description of the video says, that it is a query within the C# language. So it's not a query that you're sending off to a database. It's a query that you're making in code, not with a SQL syntax, but with code. And I'm not going to get into query syntax. I'm going to be doing Lambda syntax because a lot of developers, even if they do know query syntax where it says, select blah from blah, where blah, like exactly looks like SQL, a lot of them don't know LINQ expression syntax or function syntax. So I'm going to get into what that is. And in order to start, I have already created some code that generates some random data. LINQ works against collections. So you don't use LINQ against necessarily a date or an integer or something like that. You use it against a collection of things. And a collection of things is something like a list or an array or anything that implements IEnumerable. Actually, to demonstrate that a little bit, I could say var something equals new list. And list, where's list? iList implements IEnumerable of t and IEnumerable. IEnumerable of t also implements IEnumerable. But yeah, so lists, arrays, and other types of collections like that in C# implement IEnumerable. Not all of them, but the vast majority of them. Also, some things are treated like IEnumerable. For example, a string. Oh, I don't know if I'm going to get in trouble here. Bam, bam. Oh, string does implement IEnumerable. That's why you can iterate over it. A string is pretty much an array of characters, so I guess that makes sense. A string is an array of characters, so it implements IEnumerable. Anyway, so we have generate names, generate numbers, and generate objects, which are returning to me a list of string, a list of integers, and a list of objects. And these objects are random objects. They're not all the same thing, which is why it's just a list of objects. So let me explain what kind of a collection an IEnumerable is, because an IEnumerable itself is not a collection. It's just a class that describes, it defines how are we going to go through this collection. So if we were talking about a list of names, which I have on here, a list of names is just a list of names. And if there's a list of names in memory, then it's just a list of names in memory. But an IEnumerable shows how are we going to iterate through these names. Without the IEnumerable class, you would say, just for example, for like an array, you would say for var I equals 0, do all I is less than array.length, whatever your array is. So that'd be like a lowercase array. And then I plus plus. And then you say next value equals array I, something like that. Something like that is probably what you would do without having some way to enumerate the collection in a more sophisticated way. So an IEnumerable isn't really a collection. It's a way to enumerate a collection. So in order to demonstrate this, I created my own collection type. So this isn't a list. This isn't a collection that is pre-made in C#. This is my own way that says I need a class that can go through things like this. And this class simply looks like this. It implements IEnumerable of int, because these are just integers. It has to implement getEnumerator from IEnumerable, the base IEnumerable, which is that one. It has to implement that, which frequently, but not always, but usually just has a reference directly to this implementation. And this is what's required by this class right here. You need to implement that. So what this says is, one at a time, return to me, like in the order that you want to see the things, return to me the things that you want to see. And this is what this is doing is it's saying, well, start from 0 and we're going to do this 100 times. So knowing this, you know that there's going to be 100 elements that are returned before the end, before it gets to the end and says, well, we're done here. There's nothing left. So because I just hard coded 100 in here, but this is saying yield return current plus equals 7. So the very first time this returns, it's going to return 7. The next time it returns, it's going to return 14. Now that might sound confusing. It sounds like this method is changing and it returns something different every single time. But it's not returning different every time. It's not every time you call this, for multiple reasons that I'll get to in a second. It's not going through this entire thing. When I say, give me the next thing, it doesn't do this. I say, give me the next thing, it doesn't do this. What you do when you say, give me the next thing, apart from a nuance I'm going to get into in a second, is it says, okay, we're going to start here, current, and then, okay, we're doing a for loop. Okay, cool. And then yield return current plus equals 7. Now, if this was a list, and if I had perhaps a list at the top as like a private field or something like that, then I might say yield return list item or array item I. I might say, return the next thing in the I. So it's saying return this, then return this, then return this. But without adding a whole bunch of other complexity, I'm just saying yield return this. And what yield means is that the first time this is called through, it's going to return this. The second time this is called, it remembers yield that, hey, I stopped right here. Let's do the next thing. We're going to return this. If this was a little bit more complex, for example, if I said you'll return next, and I said next, var next equals current plus 7, and then like current equals next or something like that. You could say that when this method is called and it says yield return next, then it remembers that it did this, and then the next time that this method is called, essentially, then it's like, okay, we did this last, let's go down to the next thing. Oh, here's the next thing. That means we're going to go up to the I++, then we're going to go to the next thing. Oh, okay, next equals this. Then we're going to assign that to current, and we're going to return next. You might even say current. So it remembers it yielded here, and it temporarily returned to you a value, which could be current or it could be the next object of an array or something like that. And then it says, okay, this is the last thing we're going to do. The next time we come back to this, whenever that happens to be, it could be never, it could be further in the code, it could be immediately. We need to start here. And then, of course, it's going to keep doing that until it's this makes sense, until that's the bedtime alert. Until it gets to this point, it yield returns that it comes down here. There's no more I++, or it reaches this Boolean value, and it says, okay, well, I is now 100, and then it drops out, and then the enumerator's done at that point. It's gone. So that is essentially what happens. Let me see if it's time to talk about. Okay, so that is what happens when you create an IEnumerable, is that you need to implement it. You don't have to, but you usually implement it with a yield return, which will iterate through and return the next thing. You need some logic in there that says return the next thing. This is there's a nuance to it though. Let me hit save. Let me hit go. I messed with the code. So my stuff is that special class. It's a collection class, I'll call it. It's different than a list. It's different than an array. It's just my own collection class that can be enumerated. I called getEnumerator twice on it. So getEnumerator, does this mean that this is going to be the first value, which is 7? And this will also be 7, or will this be 14? No, it's just an enumerator. It doesn't have a 7 or a 14 or anything in it. It's just an enumerator. But I can say this first enumerator dot move next. Now that I have an enumerator, I can say do the next thing. And since it hasn't been done yet, it's going to start from the beginning and it's going to start going through when I say move next the first time. So move next. Now current val is 7. It went through that once. It hit 7. And let me go ahead and stick a breakpoint here. I should put it here to begin with, but we'll put it here. Now hit continue, move next. It went from here, loop back around, and now I is 1. I'm not using I, I'm just using this as a counter for up to 100. And now next equals current plus 7, which is 14. Current now equals 14, return current. And then do it again. Now it's 21. Then do it again. Now it's 28. So we're currently on 28. And of course, here I say break. Okay, so I've enumerated through to 28. I also have an enumerator that I gave to a second one. So if I say enumerator 2.move next, is it going to be 28 now, or 35, or back to 0? So if I say enumerator 2.current, let's go ahead and put this as an example, and I hit go, then, oh, I was wrong. I think maybe it starts to begin with. So next equals 14. Ooh, what did I hit up here? Hold on. Programming live. We're doing it. Continue through. 14. Oh, F5. F5. Continue through. 21. What is stuff enumerator 1's current value? It's still 28. This one's 21. Now it's 28. Now it's 35. Now it's 42. This one's not changing. The thing that I was trying to illustrate here is that this is just a class that's defining my enumerator. You can put stateful data up here, like a counter, put your counter up as a class field or something like that. But for the most part, you don't want things to be stateful. There are some things that end up being useful to be stateful later on, but I don't get into that. But for an enumerator, you have just a definition of how you want to enumerate through. And as you can see, you get different values here and here. That's because when I say my stuff.get enumerator, it's not actually getting, for example, a direct reference to this code. It's creating its own instance of an enumerator that will be using this code. It will be using this actually exact method. As you can see, we hit a breakpoint, but it's not saying evaluate all of this and get the whole collection and send it, store it in memory so that we can like go through it. It's saying, let's get a reference to this. Let's create our own private counter for how we're iterating, which iteration that we're going through. And that will allow each one to be move nexted on its own accord. So this one could be move nexted and it can go to wherever it's at until it's move nexted again. And this one you can call move next until however much you want for that. And those keep their own state of how far move nexted that they are. That's an official term, and it's copyright me, move nexted. So current value is going to be different for each of these because these enumerators, every time you say get a new enumerator, it gets a brand new enumerator that's going to start from the beginning. Unless your implementation, it would be messed up if your implementation has some sort of stateful data in the class or something like that. So that's what an IEnumerable is. It's not a collection. It is a way to enumerate through a collection. So it usually includes a collection or a way to access a collection. It could be, for example, if you're trying to hit a database or something like that, you could be saying move next, move next, move next, and it could be pulling the next thing from the database, whatever your implementation is. So that is what an IEnumerable is. And it's important to know that every time that you create a new enumerator, it starts from the beginning. It'll make a whole new one from the beginning. Every time you try to enumerate through in your IEnumerable class, it starts from the beginning every single time. So that's also important to know for this var my value in my stuff. The my stuff, which is now is an instance of my class that can enumerate whatever the thing is it's enumerating. This automatically creates a new enumerator when you call for each. And so if I do another for each, it's making another enumerator. So this is an enumerator of my stuff. This is an enumerator of my stuff. This is creating an IEnumerable behind the scenes a new tracking enumerable because it's getting a new enumerator. It's creating a new enumerator behind the scenes for each one of these. All right. Okay, so that's how an IEnumerable works. Now we need to know what is LINQ. How do we use the IEnumerables to query the data, especially because like the data's there, maybe it's not, maybe it's hitting a database, and so it's not really in memory right now. Most of the time, this is talking about stuff that's in memory, like a list or an array. But how do we query it? How do we get that data out? And what we're going to do is do something called select, much like you would hear about in SQL. So let me go ahead and run through this. I'll stop right here. We have this collection called random numbers, and random numbers is a list that has 100 random numbers in it. Oh, there we go, 100 random numbers. And what you can do is say random numbers dot select. And what select is going to do is it's going to go through that entire list, and it's going to evaluate a function. This is I'm going to stop it so that we can see it more clearly. What this is right here is called a lambda expression. And what a lambda expression is essentially a delegate, and you can research what delegate means, but it's a delegate that says, it's an anonymous function that says we've got some parameters here, x, y, z, something like that, or int x, int y, string z. So it's like a parameter list of a function. In this case, our function is only going to have one parameter, and if it only has one parameter, then you don't need the parentheses. So our function has one parameter. Our function doesn't have a name because it's an anonymous function, but it's a function. It's only accessible here, so it's less accessible than private. It's unique only to this scope right here. So it's like something like super private. Function name is anonymous. There's no function name. The parameters are x, and this is the function definition, just like you would expect a function to have curly braces. So this is the function. You could literally put anything that you want in here. What I'm going to do in this function is when they pass in x to me, and x is going to be from these random numbers, it's going to be each one of the numbers. So random numbers is a bunch of ints, so x is going to be an integer. So when they pass me an integer, I'm going to say change it to a string. I can do anything I want here. I can add to it, or I can query a database. I can do whatever I want. A lot of things that you don't want to do. But in order to simplify this, instead of saying it's a function list with just one thing, and what the function does is some sort of things that's x.toString. To simplify this, you can say, I don't need all of that bureaucracy. This is my anonymous function right here. And so what you're going to do is it's going to say select, and it's going to say do this, and whatever you return to me is what I'm selecting. So in this case, I'm selecting the integer toString, so this will evaluate to an IEnumerable of string. And it's important to know that it's an IEnumerable of string. Okay, so I do this, I hit run. This is not, it can evaluate it now that I put my mouse over it, and that's a whole nother topic. But this is just an IEnumerable of string. It isn't 100 values. Even though this is definitely 100 values, this is not 100 values. This is one of those enumerable classes that say how you can iterate through something. So at the moment, before I put my mouse over it, at this moment right now, because nothing's looking at it, the cat may be dead or alive for all we know, that is an IEnumerable of type string. And what that means is if we ever want to look at the values in the mapped values enumerable, I don't want to put my mouse over it. If we want to look at those, we're going to have to enumerate them one at a time and look at them. But we're telling it from this enumerable right here, the way that we want to enumerate it isn't just this, it's this plus also do the thing I defined in the Lambda function here and return that instead of what came in. So it'll say do this. This is injected into this spot is injected what we told it to select. We told it to do this. So that's what happens. Now, the moment I put my mouse over it, it actually, and it's a really small, simple thing to do. So it instantly evaluates it, and there are 100 there. And I know that it evaluated it, even though it says expanding it will enumerate it. Otherwise, it wouldn't know that there's 100 there. But you enumerate it, and they're there all. It's the same exact numbers, but now they're as strings. So select just says select those things, however you want to do. I don't have another good example, but I'm going to do one of these. Mapped people ages. I'll keep it like that for now. People, nope, random. That's why I don't do it yet. Not ready to get into that complexity until a little bit further down. Okay, so now I keep saying that it's not evaluated, that IEnumerable is just instructions on how to enumerate the list. It's not evaluated. I keep saying that, and what does that mean? What that means is, like I said, it's just instructions, but in order to actually get the values out of it, you either need to say move next and get current, and that will give you one object, the one next object. So you either need to manually do this, or if you say dot to list. So if I take this enumerable and I say dot to list, then it will change it from an enumerable, which is instructions on how to list the objects, and it will instead list the objects. Every single thing will come through, and it will create an actual in-memory list of all the things that you have. So if I skip past this, now if I put my mouse over it, it doesn't say expand to enumerate the collection. It has now been fully enumerated. Every single value has gone through, and there you go. In some ways, this can be dangerous. It's very, very common and usually not something you need to worry about being dangerous. But in some ways, this can be dangerous if you have an enumerable that whose goal is to get values one at a time out of a database, for example, and the database is millions long. You say to list, and all of a sudden you crash or you freeze up or something like that because it's going, and it's going to keep going. It will enumerate the entire list. So as long as it can keep going back to the database or from whatever source that it's trying to hit, even in this sense, I could say, I mean, it'd be hard to get a number that's too high. But if I had this going through one number at a time, not stopping at 100, just sort of infinitely, and then maybe looping, like whenever you, even here, whenever you get to 100, if I say, if I equals 50, then I equals 0. Now this is going to loop infinitely. I don't want to make my computer crash. I'm not going to show you how to test that, but it will to list it, and it will keep pulling values from that instructions of how to enumerate over and over and over until it runs out, which in that case it never will run out. So that's what to list is, and that's why you'll see down here I have to list in a lot of places, because at this point when I start explaining some of these things for pulling out values out of a collection, I want to show you the values. I don't want to show you that I have an enumerable. Now you understand what an enumerable is. It's just instructions that tell you how to enumerate. An enumerator is the instructions of an IEnumerable on how to iterate through the collection. Okay, so the next thing is, what else can you do with an IEnumerable? First thing you can do is first. So mapped values is all these values that were random numbers. So the random numbers were changed to strings and then to listed. So they were evaluated. And then I'm getting the first one. So this is an entire collection. It's not a very good example of what to do there. I'm going to do this instead. Yeah, there we go. I was using the list as an example, and that's not as good as using the enumerable. So I'm going to do this. So this is an enumerator, an IEnumerable, and we can get the enumerator and say, give me the first one. And what would happen then is it would say, okay, well, let's go through the list until we find the first one. Now, instantly, it's going to find the first one, and there you go. It's the first one. So the first value is 668, as you can see from these. First value is 668. I know it's going to take a second, but let's just do it down to here. The last value is 6156. So this value is 6156. Dot first and dot last, what is mainly different from the previous stuff I talked about is that this is returning a single thing. It's not a collection that's being filtered or changed and returning another collection. It's not just continuing to iterate and alter the collection. It's saying, give me the first object in the collection, and this one's saying, give me the last object in the collection. And if you have a fresh enumerator and you say dot last, it will iterate completely until it gets to the last thing. And just like down here, until the enumerator senses that get next or move next does not evaluate to continuing, and it actually drops out the bottom of this function. So it's no longer yield returning, but actually drops out the bottom of the enumerator. Then it says, okay, well, that last value that I gave them, that's the last value, is essentially what that will end up doing. So both of these will enumerate through the whole thing until it finds the right one. This will enumerate the whole thing starting from the beginning, but it'll stop after the first one. So that's not very far. This will enumerate the whole thing until it finds last, which means it's going to the very end. So those are examples there. Now, if I were to give it a value, a list, let's say this list was completely empty, which I'm demonstrating here with just new lists, just empty new lists, and I say dot first, it'll break. Maybe I'll just show you that it breaks, because I'm showing you what to do. Stop. Go. Bam. Sequence contains no elements. If you try to enumerate something, if you do something that is going to evaluate the IEnumerable, like a to list, and actually try to pull something out, then and it doesn't have any elements, then it's going to say sequence contains no elements. There we go. There's the X. All right, stop. Let's zoom back in. Okay, so we don't want to do that. But if you say get the last or default, and this isn't a fix, I'm not saying to always do or default. If you're expecting one to be there, if you're expecting one to be there, then you should just do last. Otherwise, if there's some sort of weird exceptional case where for some reason there wasn't one there, and I was definitely, as the developer, saying there should have been one there. I've done checks previously, and if there's not, there's something weird and it's exceptional, then it will throw an exception. Sometimes you let it throw the exception and the appropriate level will catch it and you handle the exception. Or sometimes if you are expecting it, then you can say last or default, or you can handle it some other way right there. Anyway, so last or default. What this says is either give me the last one, or only in the case where the list has nothing at all in it, only in that case, then give me default. And default just means whatever the default of this type is right here. And I can illustrate that by showing you, oh, I spelled that correctly, that for a string, the default value is null. So since there's nothing here, it's going to return you null. But for an integer, the default value is 0. So since there's nothing in this list to give you the last one, default will be 0. I know that the code lens there is hard to see, but I'm doing my best. All right, so first things first. There we go. Okay, so that's first, last, and or default. Let's move on to any. There's not that much stuff here. That's pretty much all of it right there. So we're not going to go very far. I'm not going to explain all of LINQ in this one session. Okay, so any has any. Okay, let's go ahead and go down here. What any does is it says, are there any in there? So this might be useful to call prior to getting the first or last, or prior to doing something else. You want to make sure that there are some in there. So random names has 100 values in there. So .any is a Boolean. It returns true or false. Does it have any? Does it not have any? So of course this is true. I don't put it on here, but I will talk about something additional with .any after the next section. So we've got first, last, select. We've got to list. Let's look at this now. The where clause, which is a lot like, also a lot like SQL. So I want, from the random names, I've got a bunch of random names up there that I'm generating, and they are Jane Taylor, David Martin, etc., 100 random names. And I'm saying random names, I want the random names where x.contains, x would end up being the name that comes in. So I could say name. So the name that comes in for whenever it enumerates this enumerable, this IEnumerable of random names, whenever that is being enumerated one at a time, I want it to be enumerated like this. I want to say where name.contains this. So back down to this is a lambda again. This is the input values of the lambda, and we're expecting one input value, which is just each time it loops through, it's going to give us the one value for each iteration. And this is what I want to filter on. That's different than we talked about before. Before we're saying always do the same thing here, and always, and then whatever I select, whatever I tell it to do that, and then return the value. That's what happens in a select function. In a where function, it says the lambda function will return a Boolean. So remember, this is an integer here. The one that I'm looking at, I believe, is a list of integers, or maybe it's the list of strings that. Oh, these are names. So these are the list of strings. Okay. So that's a list of strings coming through. But the lambda function is something that should return a Boolean. This is the where clause. So where it's something that will return a Boolean, and if the Boolean is true, so if true, then it will yield return current. That's great. So it'll yield return current. If the Boolean ends up not being true, then it just skips this over and it'll iterate through. It'll find it'll increment the next I, and it'll just do the next thing. So it'll keep giving you more and more things. So you can see that actually happen here. If we put a breakpoint in this function, I can actually turn it into a function. Save a breakpoint here. As it iterates through this one at a time, the first name is Jane Taylor, then David Martin, and so on and so forth. So the first name, Jane Taylor, it says return name.contains space Smith. So last name Smith, because it's always first name space last name in this exact example. So if the name contains that, then that'll be true. That is a Smith. We found one. Of course, we could put as much functionality in here or as much logic in here as we want. But in this case, I'm just saying return name contains Smith. So obviously, Jane Taylor does not. That's going to be false. David Martin does not. Laura Enders does not. Sarah White. I know there's some Smiths in here. Let's go ahead and find one. There it is, Chris Smith. So Chris Smith is the first one that we see. I'm betting Chris Smith would be the only one the first one that ends up being in there. So I'm going to put a breakpoint here, let it run all the way through. We've got Chris Smith, Jane Smith, David Smith, etc., etc. So that logic, this functionality here is a filter, whereas this functionality here is a transformation. This is saying every time we go through one of these, this is the thing I'm going to select out. It's going to be a one-for-one. Every one of these, I'm going to select out this transformed value or this sub-value or this property or this or whatever I want to do. It's going to be a one-for-one. The size of this will be the size of this. The where clause, on the other hand, is going to be only the things that are filtered like this. So in this case, it ends up being 10. So out of 100 names, there's 10 Smiths. Actually, there's 10 of each thing. 10 Taylors, 10 Martins, 10 Andersons. It just happens to be the way that I built it. But yeah, there's 10 Smiths. There you go. There's all the Smiths. And of course, I'm calling .toList. So I'm not saying create an enumerator that has this condition in it, and we'll enumerate that later. I'm saying create the enumerator, which is the where clause, and I'm saying evaluate it. Go through the entire enumerator, do all the things, and give me back an actual in-memory list. It's very important that you understand that part. So these are only Smiths. All right, so that's the where list. I said that once I go over this, I'm going to come back to the any. I can say var Fletchers, because I'm a Fletcher, equal var, has Fletchers. So instead of .any actually has a filter, just like the where clause. So I can say Fletchers equals random names .any where X dot contains Fletcher. There you go. And there's none in there, so it should be false. I'm actually going to put this back. Okay. All right, so if I run this, has Fletchers, false. There's no Fletchers in there. This is actually very similar, not exactly the same. It's actually more efficient to do this, but it's very similar to this is saying from this enumerable where the last name is Fletcher, where it contains space Fletcher. So this is going to return nothing. There's not, when it enumerates through and it only selects out ones that have the last name Fletcher, this will evaluate to having nothing in it because there's nothing there. And then .any will then once again evaluate it from the beginning and say, do I have any? And what .any essentially does is it starts to go through this and it says, okay, get next or move next. That the functionality that says, I have your enumerator here. I have your enumerator. Now dot move next. And if the dot move next never yield returns, if it just falls through and then the value that yield returns, which is cached by the internal system, if that value never doesn't get a value, so it iterates through once, the increment never increments to 1, it stays at 0, and there's no cached value, then there aren't any. So that's what happens. All right, so let's move on to of type. If you've done regular expressions, and especially not just a regex.match, but a regex.matches, which returns a match collection. So if you have a big document and you say find all the instances of ABCD, so it'll actually find a match collection, not just within one match having little groups, but that thing multiple times in the document, and each one of those has groups, so there's multiple matches. If you've ever done that with the regular expressions, then you've probably seen of type, and there's a reason for that. Of type, what it does with a collection, including a match collection, is it says, I'm going to go through the collection of objects that are given to me. In this case, this is literally a list of object. I'm going to go through those objects one at a time. I'm going to iterate through those one at a time, and I'm going to check if it is assignable to, or if the value given here is assignable to that. So it's that object is, if that object is animal, or if that object is person. It's a lot like saying where, give me through these random objects where the type of the thing coming through is animal or is person. So it's like a where clause looking for making sure it's that type. Now it just so happens that since this function is definitely going to be returning either 0 or more, some number of person exactly, it just so happens to cast the object coming through. These are all just list of object. It'll cast it as a person. So this ends up being a list of person. If you did a where clause, it doesn't automatically cast each one. You say, okay, give me all the random objects where the type is animal. Then it'll give you all those objects, and they'll just be objects. Here's all the objects that were of type animal. So this kills 2 birds with 1 stone. And of course, I'm saying 2 lists so that I can actually see those. So these random objects actually have 4 different types of things in them. They've got persons, animals, products, and something else I did. Product, person, animal, vehicle. Okay, it's got like 1 or 2 vehicles, 1 maybe. So I'm just saying all the animals. So there's 8 animals in there, and there are 7 people in there. There you go. I have 2 listed them. So that's what of type does. And in a match collection, just in case you don't know this, because I'm a big regex guy, in a match collection, it gives you back a collection of objects. And so you have to, if you're doing a for each loop or something like that, you want to say where var my match equals, or var my match in match collection dot of type match, because it's giving you back a collection of object. But in reality, they are a match. Their underlying type is a match, not their underlying type. Their actual type is a match. So you have to say of type match. It will select all of them. They're all objects, but you want to select those. It will select all of those, and it will give you back a match. That could end up biting me. I don't know if they actually are all matches. I think they are, but Maybe I'm wrong. Leave a comment. Okay, so that is of type. Select many. Now, select many is confusing. It's very much like select, but I couldn't put it up in the select section until we sort of got through some of these things. So select many means that the thing I'm going to select isn't just a thing. I'm not saying give me a one for one, give me the thing, or I should say right here, this X. Give me the thing that I need to transform. I'm going to transform it and return to you back a thing. By the way, you don't even have to. If I say this, I'm literally giving back the same thing. And so this goes from an IEnumerable of int or list of int, which is IEnumerable of int, to another IEnumerable of int. That's actually a good way to clone, believe it or not. But either way, I'm giving back one thing, transformed or not, in a select method. In a select many, I'm taking the thing for each of these people. I'm taking the one person. I'm taking each of the one person it gives me. So that will go through how many times? 7. So for each of the 7 people, and I want to return another collection. And that this can be used for a lot of ways. It doesn't have to be an object that has a list of child objects. It could be for other things, which I can actually show you an example here in a second. But in this case, a person has children. So this is pretty good too. If you hit F9, you put a breakpoint and you put it right here. It doesn't just, like if I put it here and hit F9, it doesn't just highlight the entire row. Since this is a subfunction, it highlights an anonymous function. It highlights directly in there, which is pretty cool. So maybe you've seen that before, maybe not. But for each person, this person has one child. So it's a collection. So there's child. This one has 3 children, etc., etc. So I'm saying not select one. You give me one thing, I'm going to give you back one thing. I'm saying you give me one thing, I'm going to give you back a collection of things. It's going to be the same type of collection every time because it's going to evaluate the same function every time. So every time it's going to give it back a collection of children. And so, one second. And so this collection of children is going to be given back for each person. Therefore, this is going to have a lot more people, some multiple more than this. Unless none of the people have children, then it'll be less. Maybe it could be less. But most of the time, if you have a thing that has multiple things, then it's going to be multiple times bigger. So if I hit go, take that breakpoint off. So I have, here's one of the exact instances. I'm glad it came up like this as a demonstration that doesn't have to be. So of these people, oh, this person, most of them have, or some of them have 0 children, and some of them have 1 children, and a couple of them have 2 children. Okay, so in the end, it ends up being 6. So that was a good illustration that it doesn't have to be the intuitive thing, but it is returning a collection. So it's a collection of collections. Here's a collection, it's people. Each one of those has a collection of children. So it's a collection of collections that are then, I don't know if aggregated is the right word, but they're combined together. They're put together. And so you get back all of those collections right there. So that's what select many does. Now that you've heard that, maybe it makes sense. Or maybe you already knew all of this and this is just fun to watch. You like my voice. Okay, so we have sorting. Let's move into sorting now. In a lot of these, I'm selecting something out. I'm selecting out one value here. I'm selecting them as a list into memory here. I'm selecting a first, selecting a last. This one I'm saying if it has any, so that's not really selecting. Here I'm saying select only the ones where this, etc., etc. But now I'm not gonna. Now I'm not really selecting out values. I'm sorting the values. So I'm going to say people.order by. Again, this is very much like SQL. Of the people, which here's the people right here, and it's very randomized. In this case, I'm going to say order by age. So before I order by age, you can see it's 29, 27, 26, 27. It's obviously not sorted by age. But when I say order by age, maybe I was going to talk about the IEnumerable here. Oh no, I use this in a second place, that's why. So this is just the enumerable. I say order by age, I do not say toList here. So I've created an enumerable that can either be enumerated more further or evaluated right now. So here I say take that enumerable and evaluate it toList. Bam. Okay, so now it has been ordered by age. 26, 26, 27, 27, 28, 28, 29. Okay, order by age. It's pretty simple. And then I can show you how to order by in SQL. You can say order by this, then this, then this, then this. You can say order by multiple things, so that if you have this many things and there's different groupings, then each grouping you can then order itself by something else. And it's the same thing here. But if I were to say here is people.order by age, and then if I take this enumerable and I say this enumerable dot order by name, then it takes the entire enumerable, which at this point is ordered by age, and it says order this entire enumerable by name. I'm saying order by name here. So it's not going to give you necessarily the result that you expect. So now it is ordered by name, and it's a string, so it's not numerically ordered. It's alphabetically ordered. So 3, 49, 50, 70s, 80s, 90s. So it ordered by name, but now the ages are out of whack. So you can't say order by this and then take the same thing and then say order by this. You have to say, here's the enumerable where I'm saying order by age. This is irrelevant. This is when I evaluate the enumerable. But I still have this enumerable. And I've commanded it to order by age as a step of things that I want to do, but this hasn't been evaluated. This is just an enumerable. This is a variable where this has been evaluated, but this is still just an enumerable. So I have this enumerable saying, whenever I evaluate you, order by age. So if I take this enumerable and then say, then by descending, if I say order by and then by, well, I'm going to show you then by descending, just as an example. So I say take this, which is ordered by age, then what that'll do is it'll add on top of the order by. So for each similar age, each grouped age that is ordered, where the ages are the same, I want to take those and then order those by name. So you can see here, before I order them by name, the name here, 3 is smaller than 9. So this is ordered normal, but I'm trying to say order by descending. So this should be the 94 on top and then the 3 on bottom. But whenever I'm done with this then by descending, they should still primarily be ordered by age, but then where the ages are the same, the name should be changed. So you can say here, there you go. The ages are still ordered, 26, 27, 28, 29, but where they're the same, the names are now ordered descending in descending sort. All right. Almost done here. So now we can do group by. And group by is a little bit more complex, but it's not too hard to understand, I hope. And it's just like SQL. So we have a bunch of animals. We have 8 animals. This is just using a random number generator, so I don't have real names here. But we got species 1, 2, 3, and 4. We got a 4, we got a couple of 1s, a 2, a 3. And then whether or not they're pet type animals or non-domesticatable animals would go here. So is pet false, is pet true, etc., etc. So I say animals, group them by species. So these animals where their species is 4, 1, 2, etc., etc. So I want to group them by species. So I'll hit go. And now I have a grouping of those animals by species. What does that look like though? You need to see what a grouping looks like. So a grouping looks like, here's the key. The key is the thing that I told it to group by, like return the species. If I group by name and there were a bunch of people with the name Smith, then the key would be Smith or Fletcher or something like that. So these were grouped by species. So these should be unique. These are the groups, the unique groups that it found, and this is the species 4 group. In the species 4 group, there's only one pet there, which I think we saw that before. In the species 1 group, there's 3 different pets. There's this kind of pet, which I shouldn't say pet animals. There's this, which is a pet type. This is not a pet. This is not a pet. But here's the 3 different animals that are in species 1. And then the same thing for species 2, there's 3 of those, and then species 3 only has 1 animal type. I know I keep mixing up pet and animal, but I'm trying my best. So all species, if I say give me just all of the different species, like the unique names of the species, then I can say all species. And then all I've done is I've selected the key. So you can come back up here. You can see that the key equals. So for this grouping where the key equals species 4 or species 1, that is a grouping, and you can see all those in there. But if I just say, just give me those keys, just give me the unique values where I grouped by those keys, then I can do that. I talked about distinct down here. I could also do, I'm just going to go out of turn here, var distinct species equals animals dot distinct x. Now group by dot distinct is going to be the best way to do it. Yeah, group by dot distinct is the best way to do it. So, all right, there we go. All species. Okay, so I should not have gotten out of turn there. All right, so what else you can do is say, I know that one of the species is called species 1, for example, species 1. So I could say, actually, let's go through each group. For each var species in group animals, we can decide what we want to do with those things, but I'll just go ahead and go through it. So the first species, which is species 4, has a collection. So it has a key and a collection. And there's the collection. Oh, because there's only one, the 0. All right, so go to the next one. It has a key and a collection. So here's the first animal, here's the second animal, here's the third animal. The key for species 1 has 3 animals in it. And then species 2 has a key called species 2 and then a collection. So that's the way you'd be able to access those. You can also, do something like var first species animals equals, and this isn't the species called 1, it's the first species in this collection. So first species animals is grouped animals 0. And now, and that was species 4, which only had 1 animal. So there it is, 1 animal. So there's a lot of ways that you can access those things, and that's the group by. All right, count. Count is a very important thing to know. This is the aggregation section. Count is very important to know, that you can see if you have an enumerable, then you can see that count has these on it. With an array, you can use .length, and that just gives you the upper size, the size of the array. If you have an in-memory collection, like a dictionary or a list, then that stores a count in memory. So if you say .count on a list, then it just gives you the count, and random numbers is actually a list, because up here I said generate numbers returns a list. Okay, so let me get an enumerable instead, like mapped values enumerable. So if I put that there, you can see that it breaks. This is an IEnumerable, which means it doesn't store the count in it. If you have an IEnumerable, like I said, that's just instructions. An enumerator is just instructions on how to iterate through whatever it's accessing. It could be an in-memory list, could be a database, could be whatever. So it can't store a number that represents how many are there, because it doesn't know how many are there. So there's no count property on an IEnumerable. So you have to call the count method. And the count method on an IEnumerable still doesn't know how many there are, but it will actually go through the whole thing. It's not going to select anything. It's not going to evaluate and return the list. It's not going to do any filtering. It's going to iterate through the whole thing. So you want to be careful in a database doing this, just doing a raw count. It'll go through the whole thing, iterate it one at a time. I say be careful in a database, because if your enumerable is like linked to Entity Framework or something else, then actually that evaluates as a count in SQL. But if you have a custom IEnumerable that is doing something that's heavy lifting every single time, it does the heavy lifting every single time all the way to the very end. And then at the end, it says, okay, we went through the for loop, or we went through calling move next this many times. That's what the count is. It's very heavy. This is a lot scarier than obviously this, which is just a property. Okay, so the way that you can get around that though is if you're going to be doing stuff with this anyway, you're going to be doing selecting values out of it and counts or any's and where clause and stuff like that, then do all the heavy lifting first. Var evaluated equals this dot to list. That way it'll run through the enumerable only one time in order to select out every raw value and come back as evaluated. Then you can do as a property. You can do .count as a property. And so this still does the heavy lifting, but now this is fast. And then you can also do if evaluated.any. It just so happens that for a list, if your IEnumerable is a list, it overrides .any to check the count to see if it's 1 or more, if it's greater than 0. So that's a lot faster. And .last, things like .last. Oh, if .last, okay. This is a Boolean. Calling .last, if it's a list, then it's going to just take the index of the largest number, the very last number. So it's instant. So if you need to do a bunch of things, especially including count to some collection that's in an IEnumerable, first evaluate it to a list and then do all the things over and over again that you need to do, because it'll be a lot faster. On the other hand, if you don't need to do that, and you need to filter it down and maybe only get .first out of it or something like that, then just do that. Don't evaluate it to a list just to get a .first out of it, because the .first on an IEnumerable is instant. It just does the .first. It does whatever the heavy lifting or not is to get the first thing, and that's just the end of it. If you to-list it, then it has to evaluate everything just to go back and say, okay, we just need the first thing. So there's times when you need to and times when you don't need to. And lastly, if you happen to have an IEnumerable of some number, so let me go like this. Enumerable. So class enumerable has sum, which extends IEnumerable. This is just a partial class in order to represent extensions on IEnumerable. So for IEnumerable of all the different number types, and I say number types, let me see here. I was looking for something else, but I don't really see what I was looking for right now, so it doesn't really matter. Oh, I signed number. Okay, so number types, this is a type of iNumber base. So these number types, I thought there was an iNumber, not just iNumber base. Anyway, it's too much to look for. So all the different number types that C# that you typically work with in C# are covered here and have a special extension. This isn't just an extension on all IEnumerables, but the ones that have number types have sum and average and min and max. So these methods exist as extensions on the IEnumerable of type T class, where the T is a number. And what it does is it says, let's sum. It says, let's take this collection, which is all these numbers, and let's sum them up. So this ends up being 451,920. Let's find the average. The average of all of them is 4,519.2. Let's find the minimum. The smallest number is 26. The highest number, the max, is 9,354. And what these are doing is something called aggregating. So let's look at one last Lambda function, var manual ag equals random numbers dot aggregate. And let's look at the override, the method definitions. Yeah. So the main one here is It takes in a function. It takes in a function of int, int, int. And what that means is it's a lambda. It's an anonymous function, which we can represent with a lambda, that takes in an integer and another integer and returns an integer. So I can say, take in an integer 1, an integer 2, and return another integer. So I'm saying aggregate it. And what this is going to do is, as it says, it'll give you, it's an accumulator function, and it'll give you, I guess it doesn't really give you the details, but it'll give you what the current accumulation is, what the current number is here. So every time it's iterating through and it has a new number for you, it'll have the current aggregated number plus whatever this current number is that's going to give to you. And I can say return x1 plus x2 as my integer that I'm going to return. And we can actually see how it works. So x1 and x2, I guess maybe it skips the first one. So x1 is 668, x2 is 702. So I'm going to return that back. And then it has 1370, which is the sum of those, and 7748. 7748. And then so the next thing it should do is give me the sum of all those, since I'm just adding them up here. And it should give me 5112 next. So the sum of those, and then 5112. And you can aggregate these however you want, including just keeping track of them and then returning the average at the end. Or every time it goes through it, see if the current value it's giving you is less than the value that you've already cached. And if it is, then replace that. Eventually, you can just come back with the minimum or the maximum. These are all just sort of extensions on aggregation, the aggregation function. All right. There's a lot of other things you can do, these and other things that you can do with LINQ. But if you take away anything, take away the fact that you can evaluate the IEnumerable, which will return to you an in-memory list. Take away how an IEnumerable works, which is by creating an enumerator, which starts from the beginning. Every single time you get an enumerator, it starts from the beginning and it enumerates through from the beginning. Every time it starts from the beginning and enumerates through all the way from the beginning. And that all of these extension functions, selects and wheres and whatnot, they inject a special bit of functionality into the enumerator. Each one of them has their own way of doing that. What else should you take away from that? What is a lambda? A lambda is an anonymous function that has the input parameters, the method parameters, and allows you to define a method body, and it's anonymous. I can actually show you how it can be less anonymous. Public int ag please, int preval, int next val. Let's do return preval plus next val. There we go. Okay, this just needs you to give it a function, as it shows here, a function that takes in two integers and returns an integer. Here we have one. It's a named function. This is the delegate of the function. It's an integer. It returns an integer. It has a name. It has two input integers. And so the name of this delegate is ag please. So I can just give it ag please. Oh, static. Okay. Thought I was wrong for a second there. Okay, so aggregate. I'm like, here's the function. Here's the function I want you to do. It's the same thing as saying, here's the function I want you to do. Here's the function I want you to do. Do this function. So it's just giving it the name of the delegate of what you want to do, and it'll find that delegate in code. It's got a direct reference to this method. This method is the implementation of the delegate named agPlease, which behind the scenes is going to get, I'm not going to go into delegates, it's going to get a delegate name. So a delegate definition. So here it is, agPlease, and it will do this. So let's go ahead and just show you that that works. Okay, so if I hit F5, it's going to start doing this and go through every one of these 100 numbers. There it is, previous value, next value. Previous value, that's the current accumulation, next value. Previous value, next value. Previous value, next value. Previous value, next value, etc., etc. It's actually going through this every single time. I don't think I can put a breakpoint. No, I can't no longer do that. So yeah, there you go. That's that's the really short version on what is LINQ. And it's actually really important to understand LINQ and learn dot notation, especially learning how to chain these. So if I do something like var sum of small numbers equals random numbers dot where x is less than 500 dot sum, you can chain these along. So I have an IEnumerable. I say only give me the ones where this, which is still an IEnumerable, and then I say evaluate that IEnumerable and give me the sum. So of only ones that are less than 500. I guess there's only a few that are less than 500 because it evaluates to a very small number. So you need to know that you can do these things on an IEnumerable, and most of these things just continue to generate an IEnumerable with more and more instructions on how you want to filter, map, filter, and reduce these objects to be more and more IEnumerable until at the very end you evaluate it and say, okay, run through them all, use all the instructions I gave you to select and filter and accumulate and aggregate and do all the things with these instructions. I hope you found this video enlightening. If not, if you knew all this stuff, I hope it was just fun for you to watch and see my take on it as an unscripted, random talk about IEnumerable. And I hope you like and subscribe, but I also hope you leave comments. Any comment's a good comment. I don't know. I hope to see you guys next time. Thanks.